Okay, boss. So, in the last class, we've been discussing about the factors which makes HANA fast. Yeah? So, out of that, we discussed something on the hardware capabilities, and as part of software innovations, we have discussed on row store and column store table concept. Because of column store, it is improving the performance of reading, and it also handles the performance of writing with the mechanism of main table and delta table and about delta merging. Then the next point is about pushing down the data intensive logic deep into HANA database. Let's say you have some HANA is a database, right? So it's going to be backend for any of the applications. Let's say you have some application built on top of HANA, and in order to have the good performance of the applications running on top of it, what we do is we have to push down the logic deep into HANA database. That's what we've been discussing in the last class. Say, for example, I have BW, let's say, and I've got HANA database in the backend bus. And in the BW, let's say you've written some ABAP code in the transformations. You've done some lookup and you're writing some transformations. Or you're writing some ABAP program in, let's say, in the BW system. Let's say ABAP program is designed that it reads data from database into some internal tables, process it, and then does it. Then you're actually reading from database. You're reading the data from database layer to application layer and processing your database. Instead of doing that, if I can write an ABAP program as a wrapper and into the method or into the body of the code, I would start implementing SQL script. Then when I execute this program, it actually executes this SQL script into the database server. Means the data is there in the database server and logic is also getting executed in the database server. So you're eliminating the movement of data from database server to application server and improving your query performance. So it's not about having HANA as a backend database. It's about pushing down the logic as much as possible deep into HANA database. Because I even heard from some of the people, they say we migrate to HANA, but it is still not fast. Una HANA కింద చేసుకుంటే fast కాదు. దానికి ఎంత అయితే అంత we have pushed down the logic into HANA database and leverage it fully. That's the point. So just having HANA as a backend database will not improve your performance. We have what are the data intensive logic you have to push down the logic into HANA database. You have to execute that into HANA database. Only then you would get to see high performance. That's the point of focus. Next about partitioning was. So here you can think about two partitioning. One is data. One second. There are some note which I want. Okay. Now, when you look at next is concept of partitioning. Here you can think about two partitioning concepts. One is database partitioning and table partitioning. Now, when I say database, let's say it's a set of tables. Any database, you obviously store data in form of a table. Let's say I say this is my a database for a certain application. So this application would need a lot of tables. Let's say you have hundreds of tables. And all these tables will be in one schema bus. The schema is what we refer as a database. Let's say you've set up your HANA server with, let's say, 4 motherboards or 4 application servers as one server bus. Because when you do a sizing, you decide saying, I want 4 cores and how many servers you want. Let's say I say, with 4 cores, I want 4 application servers. There will be 4 servers together, each one holding 4 cores together will become your HANA server bus. So you're going to have central instance and multiple slaves or multiple nodes again. So when you say database partitioning, let's say my application needs some hundreds of tables and I've got 4 servers in my HANA database or 4 index servers you can say. Then what I can do, I'll equally distribute say 25 tables into one and the next 25 into another server, next 25 into another server, next 25 into another server. So it's like having like multiple nodes together contributing as one HANA server. Like you'll have central instance node and multiple dialog instances or multiple slaves. In this case, what you do, you're distributing the database across multiple server nodes. That is called as database partitioning. Next, you can think about something called table partitioning. So it's all, you have a database and I have a table. Let's consider one single table. Let's say it is a column store table and I've got certain, say, some 100 records in it. And I would like to split this data of a table into multiple slave or multiple server nodes. That is called as table partition. Say, for example, I have index server 1, index server 2, index server. Even in SAP, if you look at SM51, do you see multiple application servers? So all these multiple application servers together is acting as one server, right? Same way in HANA, when you have multiple application servers, you have multiple index servers, okay, contributing to one server. Okay, then what you do is, let's say I have a table, I've got 100 records, and I would like to partition this table equally and say first 25 records will be in server 1, index server 1, and next 25 records will be in index server 2, next 25 records I can push into index server 3 or 4. That is called as table partitioning. So when you basically spread out your data, let's say there is a single table, you're spreading out your data into multiple server nodes, then what happens? Let's say you're running a query bus. When you're running a query, so it does leverage the processors of all these servers together and deploy parallelism for this. So you'll have a processor of index server 1 reading certain part of data. You'll have processor of another index server reading certain part of data, then it's been combined. So am I deploying parallelism in this way? So by leveraging database partitioning or table partitioning, we can basically deploy parallelism. And this is what the note, we can look at details. So 204468 is the note for more details on database partitioning. Means you have a big database, like you have lots of tables. You want to push down some, you want to distribute those tables into multiple nodes or multiple server nodes. And that is that node. And this node is for table partition. We'll see in detail later. We'll have hash partitioning, range partitioning, round robin partitioning on a table. We'll see that. And this node will be on table. How do I partition my table into multiple server nodes? Because there is a partitioning saying hash partitioning, where you can say partition a table using hash, and the number of partitions equal to number of servers I can say. Suppose if I have my installation with multiple, let's say 4 index servers, then obviously it creates 4 partitions. If I have with 5, obviously it creates 5 partitions. In another channel, create hash partitioning based on a number of servers. You'll have a function called server num, which basically gets the number of servers, and based on that it creates so many partitions. We'll see when you go into the system, but there is a concept like that, which again improves your performance of HANA.
This can be done at the later point of time after installing.
Yeah, even after install. Yeah, we do it after installing, and even when there's a data in a table, you can still do partition. Normally in BW, what happens? In older version of BW, when there's data in the queue, we could not do partitioning, right? But now even there's a table, there's data in it, we can still do partition with the data into it. We don't have to drop the data. Next, compression techniques. So I told you, let's say there is a database like Oracle and it's got some data. When I move this database footprint into HANA, it gets compressed by 4 times minimum, we say, right? Minimum, but there are situations where it has gone to 36 times, 12 times also. It depends on whether the data is already compressed or not. If it is already compressed, obviously the level of compression what you get will be less. Okay? So what HANA does is, so HANA would leverage a lot of compression techniques to reduce the data volumes. So it does leverage a lot of techniques in storing that information internally and reduce the size of your footprint. That's what it is. Okay. There are a lot of algorithms what they go in through, but they say majorly it will be dictionary based integer coding. It's like BW Accelerator was also using the same concept. We had something called dictionary based integer coding. Using this compression techniques or algorithm, they basically reduce the size of your footprint. They're going to compress your data to a larger extent. Now, as we already discussed yesterday about column store table, like each column values are stored in one continuous memory location. See how does it get stored with integer coding. So let's say I have a country called what? France, and it takes all the distinct values of it. Yesterday we said distinct values of this column. Let's say I've got 5 countries: Belgium, Denmark, France, Italy, and Spain. Okay. For all these countries, it does generate some unique integer bus. It takes all the district for each column. It maintains an index like this. So it reduces space. How is it? It does not store all the. Let's say if I got 1 million records, it does not store all 1 million records. It takes only the distinct values of that column and maintains and assigns an integer for each of these countries. Now let's say for France, I have an integer as assigned as what? 3. Then I told you it will have something called positioning indexing. So once it assigns an integer for each of the distinct value, it maintains a positioning indexing saying, look at this now. Uh, Now this is like row number 1, 2, 3, 4, 5, 6. This is like rows. And for first row, what is the value integer here? 3. And 3 indicates what? France. And what that's what indicates that in first row, it is referred with what? France. So this is like integer assigned for each of the distinct value. Then based on this integer, it maintains this positioning indexing. Okay. Then it gets to maintain this inverted indexing. Instead of making duplicates like this, it says for for France, let's say this what is Italy? Take it as Italy bus. For Italy, what is the number bus? 4. For 4, what all rows does it maintain? 2, 4, 8. Now, what I mean to say is, actually, it maintains this positioning index as it is. So, if I have 1 million records, will it maintain 1 million rows like this? And for each one row, it maintains an integer for the corresponding column values. Then I told you each column will act as an index, but we still need to create indexes also. When you create your secondary index on a table, it formulates like this. Instead of going for every row, for each unique value, it maintains a list of all the row numbers. Say for Italy, it is 4. It says for 4, 2, 4, 8 are the rows which I need to refer from. So when I say read all the data where my country is Italy, for based on Italy, it knows the integer number 4, and based on the 4, it identifies all the row numbers and just read only those rows. It means reads only those positions on position what? Position 2, position 4, and what? Position 8. So if you see this is a table what you see. This is a logical table what you see it, but internally it does not store the table in this form. So it basically what it does, it takes the unique values of that column and maintains an integer, assigns an integer for each of the value. Then based on this integer, it maintains the positioning indexing. So which row belongs to which integer value it is. Then if you maintain the secondary indexes on the table, for each column, it maintains an inverted index like this, saying for each value of it, which rows does it refer to. Because if I don't maintain this index, you end up maintaining what? So many rows, and if I need to search for something, I need to scan through all the rows. If I maintain an inverted index like this, what happens for this country? I can straight away refer to what? What countries what row numbers do I need to refer to? So this is what you'll get stored in your database. So when you basically store in integers, it is understood the size required to store an integer is less when compared to storing an alphanumeric values. More like concept of SIDs they bring in like that. So you end up seeing table like this, but as it is, I'm not storing a table internally in this. I'm storing the table in this format in the backend. And this inverted index is formulated only when you build your secondary index. Otherwise, you'll have this dictionaries and coding, positioning indexing. This is what we call it as dictionary-based integer coding. By using this concept of dictionary-based integer coding, they're able to store more data in less space. When you say logical table, this is what you see logically, but internally, physical ga allow undadu. Physically, it does store data in this way. This is one of the compression technique, but they use a lot more compression techniques where they want to store the data with less space. Because of this concept, it is able to reduce the size of the footprint when you bring that onto the HANA database. Minimum 4 times. Let's say it is 100 GB in another database. When I bring this into it, it will become just occupy only 25 GB of it. That's what it is considered. Okay.
So is any process to be followed to convert it to inverted index, or it's an inbuilt
It's inbuilt. It is all inbuilt. You don't do. You just create a table normally, and it stores in that way internally. This is all algorithm maintained internally in the HANA system, which is basically reducing your space. But we don't specify use this type of index, create positioning index. We don't do all this. It is all that is a mechanism of the column store tables, how it stores internally. Okay. Okay. And next, we understood like summary tables means you don't have to build redundant tables to maintain summary tables. Let's say your table is you have a detailed table, you don't have to build an aggregated tables on top of it again, so it reduces your space again. Because if you look at BW, you'll have cube, you'll also have aggregate. So cube and aggregate both stores what redundant data. Yeah. So generally, what happens? Let's say I have a very big table which is very detailed. Let's say it says order number, item number, product, so and so, so and so. Then I will, let's say I've got region and some net sales column also. Say region, maximum I've got 4 regions. So if I try to query on this table, which has got millions of data, it may take a lot of time. But what I'll do, I'll create one more table where I'll read data from this table saying select region, sum of net sales, group by region. I'll say. So basically what happens, I'm aggregating all the net sales respect to what? Region wise. Then I'll just get 4 records, north, east, west, and south, and the total net sales, which I'll put that in a separate table. So when my end user is querying, if the report is mainly using region, then it can read from summary table rather than from what? Detailed table. That's what the concepts we use generally. But when it comes to HANA, you don't have to worry about summary tables because even though it is a table, it's column store table, reading one column is as if it is reading the aggregated tables. So what they say is, you store data in any denormalized format. You store data in any detailed format, HANA will handle the performance because of that column store. That's where in S4 HANA they're not worried about normalizing it, they're worrying about denormalizing the tables. Normally what happens in general RDBMS, we make it more normalized and try to split the information to multiple tables and then go about joining it. We don't know, since HANA is able to handle with the column store table, make it more detailed, we don't mind. Even though it is detailed because of the internal mechanism where the way it stores or it is handled, it is as if it is we are handling an aggregated table. Okay. That's why in BW now, when you have BW on HANA, let's say I have a ODS with the detailed data, and then you create a queue with more aggregated information. Then what do? You load data into the ODS with say 1,000 fields, and when loading from ODS to queue, you just only load the required information to the reporting. Then you compress it. Then the data gets more aggregated. If you're using cubes just for aggregating it, we can eliminate now. We can start doing reporting on the ODS. That's what it says. Now, once you go on to BW or HANA, you don't need cubes just for aggregating it. So you can eliminate those. You can straight away do reporting on DSO, even though it is detailed. Now, the query performance on DSO or cube will be one and the same, whether it is aggregated or detailed. So once you go to BW HANA, you will be eliminating all those kind of queues, which is generally used for aggregated purpose. Yeah. So because of all this, HANA is basically performing you the performance, giving you the performance. That's the point. Okay. Now, next we'll get on to SAP HANA architecture. Now, when it's architecture, we're just trying to understand what are the different components you will have in the server and then how does it work out. See, when you look at your HANA server, it could be a single host or multi-node. Right? I was just discussing on if it is single node, you'll have only one index server. If it is multiple node, you'll have what? Multiple index servers. So you can have multiple servers together as one server or single application. You can have single application server or multiple application servers depending on your sizing requirements. Yeah? Now each node or each single node of a HANA server will have these servers mainly: index server, pre-process server, name server, and statistic server. But majorly this. Index server, pre-processor server, name server, and statistic server. Now, index server is the one which is main one which actually handles your database, which manages the entire HANA database. And pre-processor will be used for processing your unstructured data, like about text analysis. We'll see that. And the name server is about maintaining your landscape, like so you'll have development, quality, and production. All this configuration of landscape is all done in the name server. And you'll have something called statistics server, which maintains your statistics. Even at BW, you'll have statistics. For every operation you do, it actually collects the timing and the statistics data and puts into some standard tables in HANA, into system table. That is called as statistics server. Apart from which is not listed here, you'll also have something called excess engine server also. You'll also have what? Excess engine server also. ఇంకా అలా కాకుండా ఇంకా ఉంటాయి. So we'll come to this later, but if I get into the administration, like where you can see the complete configuration here. You could just say in the last, if you look at the services, you'll see all your servers. Like I've got what is index server, and I've got pre-processor server. Then I've got this is again look at this. You have what is access engine, and you'll have DP data processing server, and there'll be another component called daemon. Daemon and this is another component which actually starts all other servers. When you start a server, first daemon starts up, and daemon is the one which takes care of starting all other servers like index server or access engine server. All those started from that. So you'll have all these components on, and name server and the pre-process server, and you'll have all this. Okay. Suppose if it is a multi-node instance, you will get to see multiple index servers. Yeah. And the host, host నాకు ఒకటే ఉంది. Master. Suppose if you take 2 or 4 servers together and install, what you'll have one master and multiple slaves. This is like, almost like a screen of SM51. So you'll have master and slave 2, 3, 4, 9. When you go to services, you will see services of multiple servers. Then you will start seeing 4 index servers or 5 index servers depending on the server configuration. Okay.
But no, we cannot partition the master role. No.
Master full master లోనే మళ్ళీ ఇవన్నీ సర్వర్లు సార్.
Where you can identify service type and version.
You can see it here. What is 96 is my revision. Yes, 96 revision is SP9. 106 will be 10 actually. So our main focus will be on index server, because index server is one which actually handles your database. So now what we are trying to understand, within the index server, what all components does it have to manage the HANA database. Index server lo ఏమేమి components ఉంటాయి, and how does it handle the database with those components, okay, or engines. Okay. Now look at this. Simple. You'll have different components like connection and session management, and then transaction manager, authentication, metadata manager, and then you'll have processor engine. This is the complete block of processing all the requests what is coming into the database. Like you'll have SQL script engine, MDX planning engine, calculus engine. You'll have some relational engines about row store, column store. Processing of row store tables is taken care by row store engine. When you're processing data from your column store tables, it will be processed by row store engine. Then you'll have page management, logger. This will be about we discussed saying when HANA stores data in main memory, which is RAM, it is volatile, right? So it does not store data permanently. When you lose power, you lose the data. But how does it store the data consistently or durability? By using this persistence layer, it does manage it. So now we're just trying to see about all this. Now let's say I have an HANA server which will have your index server, which actually manages your databases. So on top of this database, let's say I'm using some BO reporting, or I'm just doing some querying. I use some SQL editor and I'm just running some queries. Say select so and so, so and so. if I need to run some querying onto my HANA database, should I get connected to that first? Even if I run a WebB report in BO, it does leverage some universe which has to get connected to the backend database. So in the universe, do you specify all the connection details first? So the first point is you have to get connected to the database. So the connection should be taken care. And once the connection is done, then you'll have a session established. In that session, you start running your queries, right? So connecting to the underlying database and the managing of sessions is all taken care by this, which is one connection and session manager. Say you run some report, you get connected to the HANA database, whether establishing connection to the HANA host, and you're basically checking you pass in username and password, checks authentication. Again, your authentication manager will be used for what? Checking whether this user is been valid to log into HANA database. Once it is valid, then the session is established. When SAP you keep opening your screen, that is like a session. You get connected to the server and you establish session. And then within the session you start working onto the server. That's how it is. Yeah? Now once the session is established, okay, let's see, then you can start running some querying. You can start querying your HANA database. Let's say I write some select statement on some table and run the query. And when you run the query, and all this request processing is done at this part of it. Any incoming request towards HANA is all processed by this block. So this block will have all the required engines to process that particular request what is coming into HANA database. Let's say you written some first the select statement gets into what? SQL processor, and this indicates about all these engines. So that's a SQL statement. Then it gets into what? SQL script engine. It does do the SQL processor, means whether it checks whether SQL statement syntactically is fine or not. Then if it's syntactically fine, then it starts executing that SQL statement, gets back. Suppose the query what you're running, if it is an MDX query, then it leverages what? MDX engine, okay. And if you're leveraging some planning applications, then it does leverage what? Suppose if it is BW on HANA, you can execute your integrated planning applications, and you can push down the planning applications also deep into HANA because of this planning engine also. There's something called planning kit what you can install and execute the planning applications into HANA database, and all the planning functions or applications are handled by planning engine. And you'll also have something called calculus engine, which is the one which is really strong for all complex scenarios, or for all your handling of huge amount of data volume. It is all handled by your calculation. For example, you write a SQL statement and it's got some complexities, and then SQL script all the engine also can leverage calculus engine to process that request. These are different engines which actually processes your database. Okay, you'll have something called OLAP engine. You'll also have something called join engine. We'll see when actually views ఉంటాయి. We'll have something called attribute view, analytical view, and calculation views. For attribute views, it does leverage join engine. For analytical views, it does leverage OLAP engine. For calculation views, it does leverage calculation engine. And for all your SQL scripting, it does leverage SQL script engine. And if you're writing your MDX queries, then it does leverage MDX engine. But just understand, there are different engines which actually process your request what is coming into HANA database. Okay. And when these engines are being processed, let's say you're querying on some table, which is a column store table. But to read the mechanism of reading a column store table, then storing a mechanism of storing column store is different, right? That is all known only by your column store engines. So when you want to read data from this, then these engines will start leveraging this column store engine to read data from a column store table. If it is row store, then it does leverage what? Row store engine to read data from row store tables. It could be reading, or it could be inserting, deleting, or whatever it is. Then see, this is whatever you see is all in Rambus. Even this one, page management and logger is all into main memory. Okay. So now what the point is? So you're creating some tables, you're storing some data into tables. It is all in what? In Rambus. But what we say is it is volatile. But so what they do is they'll configure something called save point. They'll configure something called what? Save point. When I say configure save point, they'll specify it for every 5 minutes or 10 minutes. So whenever the save point is executed, the complete memory is written back to the disk. Let's say if I say 5 minutes, for every 5 minutes, the content of main memory is written back to the disk. So even if I lose power, then I always load the data back from disk to main memory. That is the concept. So look at this. So apart from your main memory, your HANA server will also have disk. The data volume will disconnect. Normal hard disk. Okay, you have two hard disks. One is for storing your data, and you'll have another hard disk to store your logs. There will be two hard disks in it. One is for storing your data volume or the data, and one disk to store your logs. Okay, and then look at this now. Then to push down the data from main memory to the disk, it starts using this layer, persistence layer, which is part of your main memory. How does it do? Now look at this. Just first understand what is what. You have a component called page management. What does this do is, let's say in your RAM, every memory is basically organized as a page bus, like 8-bit page or 16-bit page. You'll have it in form of pages bus. Let's say you insert some new record into some table. This gets stored into some memory location in RAM, okay, and this memory location of RAM would be referred into some page. ఏదో ఒక page లో ఉంటుంది, ఆ page number ఉంటుంది, but it highlights that page, that this page has been modified. So this is all handled by your page management. Page management will identify, okay, this page of my main memory is been modified. Then once it, and then there's something, another component called what? Logger. What does this do is, your page management will identify what part of RAM is being modified, which memory of RAM is being modified, and sends this changes to your logger. And logger will capture this log into what? Into the log volume. Log volume is again a disk bus. Say, so for every operation I do into my main memory, your page management will identify that change and send the change details to what? Logger, and logger will insert that log into the log volume. Log volume is again a what? Disk. So every transaction you do in the database, it will be creating a log into what? Log volume through what? Page management and logger. Okay. And data volume is the actual disk storage, which will store complete the backup of your main memory. So when does the data from main memory is written back to the data volume? During save point. What configuration, server configuration lo save point పెడతాను అన్నట్టు 5 minutes or 10 minutes అని పెడితే దాన్ని బట్టి it executes save point and writes all the data from main memory to disk. అది concept. Now let's use this. So let's say now time is 11 and my save point it is at every 5 minutes. So next save point would be at 11:05 and next would be 11:10. So the concept. Let's say now time is 11. We have started up a new server. Assume there's no table, nothing. Okay. Then you create a new table, and let's say at 11:01 you insert one record. At 11:01 you insert one record into the table. Now this record is written to what? Main memory, and page management will identify that page change in the page. It sends a change to your logger, and logger will capture the log into what? Log volume. So in the log volume, do you have one log saying one record has been created, right? Then at 11:02 again you create one more record. Again 11:03 you create one more record. 11:04 you create one more record. So 4 records you created. So it's like 4 transactions in the database. And so will your log volume will have 4 logs in it? Yes. Okay. Let's say at 11:05 it executes your save point. Then it has write back all the data from main memory to what? Data volume. All the 4 records of a table what we have, it writes back to what? The data volume. So your main memory has got 4 records. Your disk also has got 4 records. Now, if you lose power now, or let's say the server is down, and if I restart my server again the 4 records from the data volume is loaded to main memory again. Our 4 records మనకు backup ఉన్నట్టే కదన్నా, because we have executed the save point at 11:05. When I switch on the server again, all the 4 records from the database will get loaded to what? Main memory again. So I have not lost any database, right? Okay, now level 5 is gone. Again, let 11:06 is created one more record. Now 4 records in main memory. At 11:05 the situation is what? I got 4 records in the main memory and 4 records in what? In the disk. So at 11:06 now again is create one more record. Now it inserts new record into what? Main memory. Again page management logger will capture the log into what? Log volume. Again at 11:07 they create one more record. So one page again one more log into what? Log volume. How many logs do we have in the log volume now? 6. 4 or 2? 6. And how many records in the disk volume? 4. How many records in main memory was? 6. Right? Now let's unfortunately due to some issue the server is down at 11:08. So all the 6 records what we had in main memory is lost now. The data what we have in main memory of 6 records is lost now. So when I switch on the server again, first what it does, all the 4 records of data volume is loaded to main memory first. Now memory again gets the 4 records what it was doing the save point 11.5. Then it takes the logs from the log volume and re-executes those transactions. Based on the log, it identifies what was it understands the transaction and re-executes those transactions and get back to the situation what it was at 11.6. When you switch on the server, all the data from your data volume is loaded to main memory. Now I've got all the 4 records back. Now based on the logs, what is captured in the log volume, it re-executes those transactions again and formulates those 2 new records back into the table, into the main memory. So am I back to the situation what it was when when the server was down, when I restart it again? Again I get the 6 records back. That is how it handles the persistency layer or durability in even though it stores data in main memory, it is satisfying the property of durability because of this persistence layer of with the data volume and log volume.
Is there any limitation for log?
Okay, okay. You understand this part of it? Okay. The next ఏంటంటే నెక్స్ట్ క్వశ్చన్ సపోజ్ డిస్క్ ఎత్తిపోతే లాగ్ ఎత్తిపోతే you have all those kind of questions. Then the concept of disaster, you'll have concept of backup and recovery. You'll have backup for this data volume. You'll again have a backup for this log volume also. That is backup and recovery. But this is concept of what persistence layer. Taking backup of disk data volume and log volume will be considered as backup and recovery. That is different concept. The disk కదా ఆ కంప్లీట్ డిస్క్ బ్యాకప్ తీసుకుంటా ఉంటారు రెగ్యులర్ గా అది వేరే. No, tell me what.
Is there any limitations like this can, these are the number of logs it can handle?
అది సైజింగ్ ఉంటుంది. జనరల్గా ఏం చేస్తారంటే ఇట్ సేస్ దిస్ ఆల్ విల్ బీ ఇన్ యువర్ మెయిన్ మెమరీ. దిస్ ఆల్ కాంపోనెంట్స్ విల్ బీ ఇన్ మెయిన్ మెమరీ బస్, రైట్? Suppose I told you yesterday if main memory is like say 1 TB, then obviously we expect the data volume will be 4 times of the main memory size. 4 TB and log volume will be 1 time of the RAM. And if RAM is 1 TB, your log volume also will be 1 TB. And this one, the logs what we have captured, they'll be taking the backup of it. All the logs what we have for every save point or every 1 day or 2 days, they keep taking the backup of the logs again and what data volume also. Only disk storage, only various storage tapes gani all. So this is how it actually guarantees the durability of database. And then you'll have other components like transaction manager. Say when I say database, it should satisfy the property of acid, right? And atomicity means like if you perform some transaction, it has to be completely done or completely undone, right? And let's say you basically you delete data from one table and inserting data into another table. Let's say after you delete data from table 1, let's say you lose the connection, the server is down. So should the record be kept back into the table 1 back? జరిగితే ట్రాన్సాక్షన్ మొత్తం జరగాల, లేకపోతే ఏమి జరగకూడదు. దట్ ఈస్ ఆల్ హ్యాండిల్డ్ బై యువర్ ట్రాన్సాక్షన్ మేనేజర్. The means roll back, they'll have concept like rolling back and what committing bus. If it is not done completely, it roll back to the status what it was before. Okay, that will be handled by your transaction manager. And then you'll have metadata manager, like say like any other application, your HANA also will have a lot of standard tables where it stores the complete metadata. For example, you create a table in HANA, there will be some system table which stores information about this table name, description, column name, definition of the columns. Like that is about metadata bus. So every database object you create, table, view, procedure, script, whatever it is, in metadata information about all these database objects will be stored into some system repository, standard tables. That will be done by your metadata manager. Like this, you would have a lot of engines which actually this is all about index server alone. So basically, it will have request processing block, and then engines for processing a row store or column store, and then persistence layer, and which will be writing data into your disk. Now with this, can I say every write operation is to the main memory and to the disk, but every read is from main memory. And while reading, if it doesn't find the data in the main memory, it'll read from what? Disk. Automatic. Suppose now actually when you switch on the server, generally what happens, it's an important point. When you switch on the server, all the system tables, like RS all the system tables will get loaded to main memory bus, which will be row store tables. All row store tables will get loaded to main memory first. Okay, and column store, all your application tables which are column store are not loaded to main memory at all. So let's say I've got 5 tables, 5 columns store, all are in the disk bus. Now when you run the query, it does not find the data in the main memory. It starts reading from the what? Disk. During the first fetch on the table, it loads the table into main memory and then keep it. ఇప్పుడు కొత్తగా సర్వర్ డౌన్ చేసి మళ్ళీ స్టార్ట్ చేసాం అనుకున్నా కాలమ్ స్టోర్ టేబుల్స్ ఏవి ర్యామ్ లో ఉండవు అన్ని డిస్క్ లోనే ఉంటాయి. When you run the report during the, and if it doesn't find the data in the main memory, during the first fetch on the table, it will get the table loaded into what? Main memory and then gets it to the report. అదే query నువ్వు మళ్ళీ రన్ చేసి ఇంకా ర్యామ్ నుంచి ఎత్తుకుంటుంది because it's already loaded to main memory, it reads from the main memory. Okay, ఇప్పుడు నా పాయింట్ వాట్ ఎట్లా అంటే when I switch on the server, my table must be loaded to main memory bus. It not during the first fetch, even without a first fetch, I want to load my table into main memory bus. So 2 ways you can do. One is you can explicitly write a SQL command saying load table at a table load out. The table gets loaded into main memory. That is one mechanism. That is called full load. Means you're loading all the columns of the table. We call it as what? Full load. Let's say I've got a table with 100 columns. I can only load some columns of a table also into main memory bus. That is called as partial load. You can say load this table. In the brackets, you can say column 1, column 3, column 5. Only column 1, column 3, column 5 are loaded into main memory. You can also do partial loading. Full loading means all the columns of the table are loaded into memory. That is called full loading. So that is like you're explicitly loading the tables. Server start this automatically. So we can, there's something called we can flag this table as preload flag. While creating this table, you can set up some property called preload on JSON. When you set up the preload properties on, as well as every time the server is switched on, this table will be loaded to main memory bus. Preload flag set చేస్తే load అవుతుంది. నాకు అదిగా నేను manually I would like to control loading it. I can explicitly write my own command of writing what? Load. If I want to remove it, then I can say what? Unload. Now table right click go also you'll find those options. I'll get to this table. So you can just right click on any table, you get what is load, unload. This is like manual operation what you are performing to load the table into main memory or unloading it from it. But in the table properties, I can set as preload flag as high priority. Then what happens? As soon as the server is switched on, this table will be loaded automatically. So we can also do that mechanism.
Why we do this explicit operations? Loading to memory, unloading from memory.
What is it?
Why we do this explicit operation?
Our loading and unloading? We will not do. We will not do because during first fetch, anyway, it is going to bring it into main memory. So we don't have to really, means if you want forcefully load it, then you can do that load or unload. But normally we will not do forcefully load it. Generally we leave it to the system. During first fetch, it will be loading only the required data into the main memory. So we don't have to worry about it. And then the preload load priority and output. We set the priority from 0 to 9. Will come to the system, but when you set the priority from 0 to 9, the more lesser number it is, it has to store in main memory to a larger time. And for example, when you keep bringing lot of tables into main memory, at some point of time the memory is full. Yes, sir. At some point of time the memory is full, then it tries to unload some tables to free the space. Now, which table should be unloaded first? In that case, which table should be unloaded first? So then we specify something called unload priority and it will be a number from 0 to 9. The more the higher number it is, those tables have to be unloaded first. If I say 0 to 9 ఉంటుంది, if I say 9, that is a table which will get unloaded first when there is no space. And if I say the number is 0, that is a table which will be unloaded last. I think highest preference, it has to be in main memory. Generally, the tables of your ODS or cube, you try to put 7. We'll say if the space available, let it be in main memory. Otherwise, we will basically have to unload it. There's something called unload priority, what we'll set. But in SQL commands, you will see how to set the unload priority, how do we load it, how do we unload it, all those.
If the main memory limit is exceeded, assume that, so itself will freeze it.
Yes, because you will set up something called unload priority, it can free it. It has to do like that, right? It is more like cache annattu. Cache lo pettukuntam free and it will have some algorithms, and out of that, if you want to control the algorithm of it, then you use that unload priority, saying I want this table to be unloaded first, then you set the priority as high. Higher the priority and more earlier it is unloaded. That's the point. No. That's what I'm saying. We will not load those tables into main memory. We can load explicitly. I will not do that. Explicitly, I will not do that. But if I see but if they give me saying there's some query which is running really slow, and I see that the corresponding tables are not in main memory, I can load to improve the performance, because already this performance is slow. But if we are not really worried about performance, we will not keep loading every time into main memory. During first fetch, system takes it into main memory automatically. Even in BW, to improve query performance, we have something called broadcasting with filling overlap cache. We can explicitly run the query and fill cache, or you can just leave it during first read of the query to fill the cache in here. So it depends on your requirement. Default, it loads. You're saying as soon as I create table, by default it will be in main memory. Yes. So you switched on the server, you create a table, it will be in main memory because it is loaded already. Okay. But when you restart the server, then you get the problem of explicitly getting loading into main memory bus. Okay.
In case of Go like this, we can use this. There are millions of programs.
Yes. Okay. When performance is slow, only we unload. See, generally, normally with HANA server, there are a lot of problems. There are some times where they're trying to restart the server also because of RAM getting full completely.
Muted. Unmuted.
Okay. So what we're trying to do is, there are cases where the RAM gets completely full, and they're trying to solve the problem by restarting it. Instead of going to every table saying unload, and they're just trying to restart so that my RAM is completely free. They're also doing that kind of stuff also. How to check? He's saying how to check whether the table is in main memory or disk. I told you there will be something called some standard tables like tables or m underscore cs. There are some standard tables in the HANA system which gives you all the properties of the table, whether it is loaded or not, whether it is fully loaded or not, partial loaded. And we'll see when you get on SQL, we'll see all those options. First, we'll unload it, then we'll see the table status saying unloaded. Okay, then we'll load it, then we'll see fully loaded, then we'll load some certain columns, then we can see which says what partial. And then two columns are we can only get the status into some standard table to update the status saying loaded or fully loaded or partial loaded status.
Actually, how we can say that what tables are loaded here means, that they will
So there will be a standard table called m underscore cs underscore tables. So you just say select star or all the table names from this table where the status loaded is equal to yes, and it lists me all the tables which have been loaded.
just saying a point like, so we have some different concepts like data temperature. So hot data, cold
That
So
is
depending on the
different.
type of the data, I mean, if the data if the organization requires the data immediately for reporting, then we load as you said the flag.
Actually, that's a different concept. What he's saying is, normally what they do is they categorize data into hot, warm, and cold bus. Hot is like more frequently required for reporting, and warm is okay. Sometimes you need it and not so frequently, and cold you never need it. For example, in BW you have PSA tables. Do you need it for reporting? Never. And let's say some of the queues which I'm using more frequently for reporting, I would consider them as hot. Atla, they categorize it first. So then the tables what I consider as cold, we would set that as extended tables. You know, there's the concept called extended storage. From HANA, I can create some extended storage into secondary another database, like say NLS gaadu. It will be another database where I create my extended storage of my HANA onto that database. Then when I enable the checkbox saying called extended tables, all these tables will be stored into that extended storage bus. So all the data what I consider as cold, I will not store even in the disk of my HANA. I will store into a extended storage bus that is called as cold. And what I treat is that HANA, I will try to store it in main memory bus. But even if you store it in main memory, you cannot control that it is always in main memory, because at some point of time when the memory is full, it has to unload some tables. That is where you control with unload priority bus. ఇప్పుడు నాకు ఇంపార్టెంట్ క్యూబ్ ఉంది, దానికి ఏం చేస్తుంటే విల్ సే అన్లోడ్ ప్రయారిటీ as 3 అంటాం. అప్పుడు ఏంది, even though when the RAM is full, it has to unload some table, but when it comes to unloading, this table will be at last stage. First it has to unload the tables with priority as 9, 8, 7, 6, 5, 4, then it comes to the table with priority what? 3. So when you consider the table to be really hot and you want always it to be stored in main memory, then you'll set the lower the unloading priority. Unloading ante unloading priority taggute tondaraga unload kaadu, adi point.
When we can
Set this number. That's what you'll have some SQL statement for this table. My unload priority is 0 antam. Simple. Uro command ఉంటుంది, unload priority 0 antam. We'll see that when you get on test. I'm not able to relate. Can you give an example with ECC? See, simple. It's only priority number bus. I mean, pure ekku ఏదో అది ఏం లేదు విషయం. When you say loaded, the data is loaded to main memory bus. So once it is loaded to main memory, is it all permanently stored in main memory? No. So when the main memories get completely filled, let's say now RAM is completely filled bus. Now you're trying to run some report on a table which is not there in the RAM now. Then what it reads from what disk? During first fetch, it has to load into main memory, but my main memory is filled, right? Full, completely filled. Then what I'll do? It has to unload some table which is already loaded bus. Which table will it unload? As per the priority. And the table with highest priority will be unloaded first, and then this table it will be like cache, like in and out. It uses. అతను ఏమంటే నాకు టేబుల్ ఎప్పుడు మెయిన్, ఇఫ్ యూ సేస్ ఇఫ్ ఐ నీడ్ టు హ్యావ్ మై టేబుల్ కంప్లీట్లీ ఇన్ మెయిన్ ఆల్వేస్, then I'll reduce the unload priority. The lower the unload priority, it does stores the table in main memory for a longer time. That's the point.
that can be taken care by DB or another.
We will specify. It is a consultant or modeler. We specify the priority because we know which tables are supposed to be used for reporting. We control that priority, not the admin person. We would do that. It is a normal SQL statement. We control that property. Nothing much. Okay. Next concept, we're trying to go with SAP HANA components. Now, what we're trying to understand is what are the different components we can use to perform what kind of business functionality in HANA. And HANA lo ఏమేం flexibilities ఉన్నాయి, and with these flexibilities, what all business processes can be achieved here. Okay. Now look at this. For SAP HANA, it does support integration with DS. DS ante data services. So by leveraging data services, you can insert data into HANA. So let's say if you have a requirement where you have data available in some SAP or non-SAP applications, and you would like to extract that data into HANA, can I leverage BODS as an ETL tool? Yes. So knowing this point, in any scenario where you look at implementing data processing techniques, I can leverage what? BODS. And it also supports real-time services. In HANA, it does also support real-time. See, as it is, HANA database is not real-time. When you have a HANA database accompanied with SLT or smart data access, then it becomes more real-time. So SLT is one. SAP landscape transmission through which you can replicate data in real time. For example, I've got data in SAP or non-SAP. Through SLT, I can configure it to what? HANA. Then as and when there is some new postings into the table, that will be replicated into HANA database automatically through trigger based. Okay, automatic database, every time you insert data into a table in the source, on the table you'll have a trigger which will identify that there is a new record created. That trigger will initiate the transformation and the data from the source table is brought into HANA database. That is called real-time replication. So by leveraging SLT, you can replicate data in real time into HANA database. That is one. There's also a there's also a concept called smart data access, and latest one that also can be leveraged when you want to access the source database as remote virtual tables in HANA. For example, I've got SAP ECC or non-SAP which is connected to HANA through what? Smart data access, and I can consume all my tables of the source application as virtual table in HANA. Let's say I've got VBAC table in ECC. I connect that ECC to my HANA database through Smart Data Access and consume that VBAC table as virtual table in HANA. So there's no replication happening. All the data what is there in ECC is consumed in BW in HANA as virtual table. That also is possible. So it is also more than a real time. When you straight away reading the table virtually from the source, it is more than real time. Right?
In SAP applications happen, but in SDA,
no replication. In SDA, there is no replication. Straight away at runtime, you read data from the source table and then use it as a virtual table in HANA. So, like you can understand, like SAP remote queue. RDA, RDA, you can make it similar to SLT. Virtual cube is more of this. You don't have your data physically stored in HANA at all. You only have the connection details and the table structured information. When I run my reports on this virtual table at runtime, it reads data from the virtual table, the physical table of the source, and gives it to me, like remote queue. మామూలే కదన్నా. That is general understood saying. When I use virtual table, will it affect the performance of the query? Yes. That is where what I do is I would leverage smart data access only majorly scenario where like I've got BW on HANA, ECS also is on HANA. Let's say I've got BW is on HANA and ECS is also on HANA. Then what I do, even my source database is also HANA, right? In this case, what I'll do, I'll connect my source HANA towards my target BW HANA through smart data access and consume the tables of the source HANA database as virtual. Even though it's a virtual table here, when actual processing is done in what? Source HANA database of ECS. That would HANA server got my performance is handled. So even though there's smart data access option, you would leverage it only once some scenarios where you really want to have the virtual table. It's obviously understood that when I use virtual table, performance is down. See, there are two scenarios. One scenario is you're literally replicating the data from source into HANA and then doing reporting. That is one option. One more option is you're using what the table in source as virtual table. Either performance bound. Obviously, the performance in the query which I've got really replicated HANA would be fast. And physically you have data in your HANA database also. Yeah. Then it's in-memory database. Yes, HANA will store your data in main memory and process your data in main memory. Yes. Then it will have R and Hadoop integration. So I told you, see, when you want to perform database intensive logic in HANA database, we use what? SQL scripting. I can write a stored procedure by using all SQL scripting or CE functions and implement my logic. Apart from writing SQL scripting, I can also go with R language also. R is also a language which is more useful for statistical data processing. If you want to implement complex logics, I can also leverage R language also. I can also implement stored procedure by using R as my language instead of SQL script. That is what R integration we have. Okay, boss. And then Hadoop integration, boss. Now, then I told you there's something called smart data access. By using smart data access, I can connect Hadoop systems to my HANA database as a virtual table. I can consume Hadoop data as virtual tables in HANA. Hadoop can be integrated into HANA database. Okay, and that's what future we're looking at. All my SAP systems will be sitting on single HANA database, and all your non-SAP data will be brought into Hadoop, and Hadoop integrates to HANA. So the point of focus. And recently, I've seen there's something called SAP HANA overrun. There's some concept SAP HANA overrun. That is more of HANA analytics embedded into Hadoop systems. There's something called HANA overrun. Okay, and then PAL, BFL. So I told you there are some ready-made functions built with C++ as a language to implement predictive analytics or business functions library. There's some ready-made functions. That is what we call library version. The ready-made procedure is given to you. You just have to call this procedure by passing the parameters and get the logic implemented for it. That is the ready-made library available. And then planning and calculation engine. Over and you just released it. Ora is something, what they're saying is you'll have Hadoop systems, and Ora is going to be an analytics platform within Hadoop to do all the analytics. And the system. Okay. Okay. And then there's something called planning and calculation engine. Now, when you say planning, I told you majorly this comes with BW. Like when you have BW on HANA, you'll have IP integrated planning. So by using planning kit, you can push down all the planning applications into HANA database. Then it does leverage planning engine. Because of this planning engine, you're able to execute all your planning applications of BW into HANA database. Okay. Then calculation engine to process huge data and complex calculations. It does leverage calculation engine. It will also have something called CE functions, calculation engine functions on it. While writing SQL scripting, you can leverage this CE functions and make sure the logic is executed directly into what calculation engine, which is the faster one. Okay.
Muted.
Yeah. So when I say calculation engine, it's a complex engine and can execute huge amount of data volume at a very faster speed. So when you would like to write some logic which you want to execute directly into calculation engine, we use something called CE functions. So when you implement your concept by using CE functions, it executes that logic directly into what calculation engine. And the point. Yeah. Next, text search is for processing your unstructured data. So let's say I have some reviews and I would like to do some sentiment analysis on top of it. I can use what? Text analysis or text search. And then application service, I told you, we have HANA has got its own Access Engine server where you leverage your HANA native framework about SAP UEFI, OData services, and all these functions, and build your own custom applications and deploy it onto your Access Engine. You can application server where you can develop your own applications with SAP UEFI on HTML5 with CSS and some libraries. Then modeling studio under it. Normally, even if you look at MS SQL Server, it will have a studio. It's like client tool through which you start working on your database. Even HANA will have a modeling studio and HANA Studio. HANA Studio will be your client-based tool through which you get connected to server and start working on it. So HANA Studio will be your tool where you just log in to get connected to your HANA database and start working on it. You'll just log in and do that. And then there's something called information compose. It's like browser-based tool for an end user where end users can do the modeling. For example, you've created some model and given to them, and the model contains the product column. Let's say apart from product, they would like to have one more column saying product class or something. Then ask him, how do I know which product belongs to which class? Then he gives an Excel sheet saying, in this Excel you have all the products and their class. So the existing view must join to that Excel file and include that class into that projected view. Then I say it needs 3 weeks time. I need to do changes in the development, quality, production audits. By the time my reporting requirements are gone. So what he does, he would like to do his own modeling by attaching this, uploading this Excel file, then attach those Excel file to the view output, then join those, and then he can do his own reporting. So when end user wants to do own reporting, we can use that information composer tool. Okay,
Is it something workspace?
workspace range. And then on top of it, you can do reporting with business objects or Excel or any business tools, any business reporting tool. And for applications, you'll be replicating from SAP or non-SAP. You have all this. So knowing that HANA can do all these flexibilities for any business requirement which requires any of these functionalities, we can leverage HANA. So the concept. If you want to process unstructured data, I can use HANA. If I want to build my own applications, I can use HANA. If I want to build a data warehousing application, I also can use what? SAP HANA. When I want to push down the planning applications, I can use what? SAP HANA. And if I want to do reporting analytics, I can expose my HANA objects on towards business objects or any report, Tableau, any reporting tool like Tableau, ClickView, anything can access your HANA objects or whatever it is. Okay. So we'll stop it here, but tomorrow we'll start getting, and next we'll finish up this. We'll have something called SAP HANA software specifications. So when you want to buy your HANA software from SAP, you can go with any of this. You can go with Platform Edition, Enterprise Edition, Enterprise Extended Edition. If you go with Platform, you purely get your only the database and the BODS. And if you go to Enterprise Edition, you get the complete HANA server, then BODS and SLT also. If you go to Enterprise Extended Edition, you'll get the HANA server, BODS, data services, as well as SLT, and you also get something called Sybase replication and AAC, nothing but Sybase IQ. And you also get, you can use this AAC for creating extended storage also. ఇంకో database. Nearline కాదు. BW ఉంటేనే NLS అంటాం. Only HANA ఉంటే we say extended storage అంటాం. So they also give you Sybase ఇప్పుడు SLT ఎలా ఉందో there also some concept called Sybase replication అనేది we don't use, but there is some concept like that. And AAC అంటే it's another database. Adaptive server అంటే అది మళ్ళీ another database which can be used for extended storage అన్నమాట. అట్లా నువ్వు కొనే సాఫ్ట్వేర్ దాన్ని బట్టి దే గివ్ యూ మోర్ ఆప్షన్స్ ఇంటూ ఇట్. నోట్ పాయింట్లోకి వచ్చాం. సో అపార్ట్ ఫ్రమ్ పర్ఫార్మెన్స్ ఈజ్ ఎనీ అడ్వాంటేజ్ ఆఫ్ HANA డేటాబేస్? నథింగ్. అంతే పర్ఫార్మెన్స్. And they say performance and real-time report. Real-time reporting because if I just have HANA database and if I load with BODS, it does not give you any real-time because BODS gives you batch mode. But if I use SLT and put real-time replication, then HANA starts giving you real-time report. HANA lo real-time reporting. HANA has got, when I accompany HANA along with SLT, then it gets the flexibility of real-time reporting. HANA lo real-time kaadu. HANA is not real-time. HANA is in memory. Through SLT, I can replicate data in real time into HANA and then expose the HANA models for reporting, which is nothing but real time reporting. One is SLT and one is you can think about even smart data access also. Okay.
So we don't have any other database apart from
One
Sybase.
Sybase in memory. Sybase is a normal database with columnar storage. Okay. So we'll stop it here and tomorrow we're going to see about HANA Studio. Now we're okay now. What is HANA? Why is it fast? And what are the different use cases for HANA? I touched on this topic. So next is now we'll have to get into system and start create. Now HANA is a database, right? I would like to get connected to the system and start creating my database. So tomorrow we'll see. So for this, I need to have this client tool was what HANA Studio was. Point amount. For example, if దీంట్లో లేదనుకుంటా. Okay. Tomorrow anyway I'll restart all this. But so we're going to install HANA Studio and see how do I install HANA Studio. Then how do I from the HANA Studio how do I get connected to HANA server? Then start working on to HANA database. Tomorrow we'll do that. And tomorrow is Saturday, so we'll have 7 to 10. Okay. Thanks. Name server is for